Here's the question then, parts A, B and C. So I've got it summarized here. So let's have a look at it then, part A. So here we need to get dy dx, don't we? So let's have a go at that. It's an implicit function, so let's differentiate. So x goes to 1, differentiate with respect to x. Something squared, 2 times something to the power 1, multiplied by the something differentiated. Sec differentiates to sec tan. But that in turn is a function of a function, multiplied by that something differentiated is 3 dy dx. So we had to go in a couple of layers, didn't we, so to speak. So we've got that then. So find dy dx. So, okay, so what have we got here? 1 is equal to 2. Sec is over cosine, isn't it? And then there's another cosine here. And then the tan is sine 3y over another cosine, isn't it? So that's a cube now. And that would be a 3, so it's 2 times a 3 dy dx. So dy dx then, leave that as is. And on the other side, the 6 can go underneath, 1 over 6. Cosine cubed 3y over sine 3y. Okay, so let's see what it says in terms of y, which we've done here. Okay, good. I'm okay with that. So hence show that dy dx is equal to this. Now x is equal to sec squared. So we better write it equal to sec squared, haven't we? Cos squared is 1 over 6 sec squared 3y. And then we've got a cot. So we're taking 2 of those. And cos squared is 1 over sec squared, isn't it? And then we'll take a cos over sine, and that'll be a cot. Or a sine over cos is a tan, isn't it? So bring one of these cosines underneath, and we can write tan 3y. I think that's the best thing to do there, just looking at the above. So here we've got equal to then. Now sec squared 3y is just x. So this is 1 over 6x. Now the tan 3y, now 1 plus tan squared is sec squared, isn't it? So tan squared, if we remember our trig identities, is equal to sec squared minus 1. So tan will be this to the sec squared minus 1 to the half. So that will be sec squared 3y minus 1 to the half. And that would equal then 1 over 6x. X goes in here, minus 1 to the power half, which is what we wanted. So we got to that, didn't we? Hence show that dy dx equals that. Find d2y dx squared in terms of x. So part C. So that was part B. Now part C. So d2y by dx squared is equal to, differentiate this then. Okay, well we've got, right, so what have we got here? We've got, this is equal to, I'll put it here actually. That will equal x to the minus 1 over 6 times x minus 1 to the minus a half. So differentiate, you get u times dv minus 1 half, x minus 1 to the minus 3 over 2 multiplied by the something differentiated, which is 1. So that was u to v plus v times by du. This goes to minus x to the minus 2 over 6, doesn't it? Just differentiate powers. So, and simplify, I think it said originally, didn't it? So we got a sixth, we can take that out, and we can take the x minus 2 out, can't we? So I'm going to take a 12th out, and we're going to take an x minus 2 out, and an x minus 1 to the minus 3 over 2 outside a bracket. Now here, to get x minus 1, we're going to need an x. Everything else is fine. We'll need a minus, won't we, for that? The 12 is there. That times that will give x minus 1, and we've already got that there. The next term, we need this, we need a 2, don't we? And a minus 2. Okay, there. To give the sixth. X minus 2 is already there, but we've got a minus 3 over 2 here. We've already got that inside, so we're going to need an x minus 1 to power 1. So that when you times it, you get minus a half. Close brace. Now I've got a minus here and a minus here, so I'm going to take those two as both pluses and put the minus there. So that's equal to minus 1 over 1 over 12x squared, x minus 1 to the 3 over 2. And on top we've got 2x, we've got 3x. 2x and x is 3x minus 2. And that's what we've got on top. So there's our d2y by dx squared in terms of x.